not there. Hi, my name is Bernard Brault. In this video, I'm going to show you how to run and install the driver for the RS232 tester that I designed, and it's based on the Beaglebone. If it's the first time you're running it, you have to go and install the USB driver for it. So you go to beagleboard.org and getting started. And once you get there, you scroll down a little bit and you will see right here the drivers. So there's a driver for Windows 64-bit, Windows 32, Mac OS, and Linux. I've not tried a Mac or the Linux. I think the current one I'm using is probably the 64-bit because that's the version of Windows I have. So you install this driver. After you install this driver, then you actually plug the tester. There's a cable, USB cable that comes, and one side of the cable is a mini USB, and you plug that into the debug port, and then the other side is a standard USB that you plug into your PC. That should power up. It will power up from the USB cable. You don't need to provide separate power. Immediately you should see the cape on top. There's a LED there that flashes, and that indicates RS232 activity. You have to wait a little bit for the Beaglebone. It's a Linux-based computer, embedded computer. You have to wait a little bit for it to boot up, and then you actually browse to this page. I created a bookmark, but the address is 192.168.7.2:8090. It's very important that you put the :8090. If you don't put that, you will go to the default page of the Beaglebone. That's not where you want to go. You want to go to the application for the tester. So once you enter that, you will reach this screen, and you know that everything is running fine when you actually see the transmit and the receive counters incrementing. That means that there is communication between your web page and the tester, and it also means that the tester is actually transmitting and receiving. So you can reset those counters to 0, and as you see now, I'm running error-free, and the reason for that is because I got a loopback cable between the transmit and the receive. So the way you connect the 232 on the tester, there are two holes in the top acrylic plate. The first hole is 2 grounds pins. You use one of them. There are 2 of them just because, you know, that's the way the header was. And the second header a little higher up, closer to the chips. On the left hand side is transmit, on the right is receive, and right now I do have a loopback cable between the two. So if I pull out the loopback, you'll see that I'm running 100% errors, and if I swing the loopback cable back and forth, then I'm accumulating a whole bunch of errors, CRCs, and so on. Well, another feature that you have is you could change here the baud rate. So it goes 9600 all the way up to 115,200. Notice that sometimes when you change the baud rate, you will see an error. So for example, if I'm running error-free right now with the loopback, and I do change the baud rate to, let's say, 19,200, well, no, it didn't create any error there. If I go up, let me see, I'll just make a few changes, and once in a while during a baud rate change, you'll see an error like right now. And you just reset the counters because you're not supposed to do that on a regular basis. So you just, you know, select the baud rate. That makes sense. The other thing that this tester does, it gives you the latency. So right now, if I'm running at 9600, even with the loopback cable, you'll notice that my latency is half a second, 512 millisecond. And the reason for that is this is the time it takes. The latency measurement is measured from the moment that I'm starting to transmit and the moment that I'm receiving. So if you're going to transmit an RS232 frame, it takes a certain amount of time for it to egress, to come out, because it comes out bit by bit. And at the slow rate, it takes a while for the frame itself to egress, and then it takes a while for the frame to completely come in. So So this is what you see right there, and I think it's the right appropriate way to measure latency. It's really measured from the application standpoint and not just from the network standpoint. Of course, normally the way you'd use this tester is you would use it over some communication infrastructure, some kind of primary MUX or an RS232 port that is transported over the network, and there's a far end and a near end. So you would connect on the near end the tester, and then at the far end you would put a loop back, either a physical loop back or you set the far end port to loop back. And the latency that you measure here is going to be basically given to you as the half value of the round trip delay. So it doesn't take into account asymmetry at this stage, because to do this you would need to have two testers at both ends. But it gives you the latency assuming that it's equal amount to go from A to B and B to A. So it gives you the sum of A to B plus the loop back B to A divided by 2, and that's what the latency shown there is displayed. So if you're running, let's say at 57, see it's relatively fast, so you're barely what that's like a 77 microseconds, so that's really not much, and the network delay will be in the milliseconds range. So if you plug this into a network, you're going to see several milliseconds depending on your network, depending on your settings. Alright, so let's reset the counters right there, and that's it. So for example, if I disconnect the Beaglebone, what I see here is that I no longer have communication, and I can, if I could try to reset the counter, that doesn't change. But the main thing that you notice is that the transmit counter and the receive basically are no longer incrementing, so that basically you're not talking to the box anymore. If I plug it back in, it's currently rebooting, and I would assume that after it finishes rebooting, it should probably be back up and running. Possibly not at this baud rate, even though it's indicating 57,600. So after you reboot and you see the counters starting to increment again, I suggest to set the baud rate. You normally shouldn't be doing it that way, but I think the best thing is probably to refresh the page, to be honest. But I think as soon as the tester is back up and running, there you go. So the tester is back up and running. I doubt that it's running at 5700, so let me change it and let me bring it back to 5700. Yeah, there you go. So at least it comes back. It comes back up if you unplug it and plug it back in. The better way would be to refresh this page, to be honest. Alright, and that's about it. And if you have some ideas, if you have things you'd like to see added, so for example, we're not setting, it's currently running 8-bit, no parity, and 1 stop bit. It's possible to have these settings change. If you can think of other ideas, just get back to me, and maybe we can implement those in the next release or firmware upgrade. Thank you very much, and if you have questions or any issues, don't hesitate to contact me. Take care.